HA2, in my last video, we introduced these three properties of logarithms that we call our product, quotient, and power property, and we use them to evaluate for values of logarithmic expressions. In this video, what we're going to be concerning ourselves with is the act of condensing logarithmic expressions as well as expanding logarithmic expressions. So with respect to what we see with our properties here, we can see that all of these expressions on the left, okay, we have a log of a product, or we have a log of a quotient, or we have a log of a power. In these cases, we can see that we're taking the log of a very, I don't want to say a complex expression, especially not mathematically, but something that is not as simple as saying just say the log base b of just m or the log base b of just n. And so the act of taking something like what is written on the left and rewriting it in terms of what's written on the right here does two things. One thing it does is it allows us to take our expressions on the left here and rewrite them in what we call an expanded form. So in terms of expanded form, expansion here, we can see that expanded form is written out much more explicitly as many terms either being added together or subtracted apart or multiplied together here. So this expanded form, okay, takes us from the left expression to the right expression. We're also going to be interested in going backwards. And so I'm not going to be able to fit this in very well here. So let's see if I can get this to work here. But we say going back the other way. If we were to take these expressions such as the ones on the right here and write them back the other way, what we would do is say that we are condensing the expressions here. So to expand or condense, depending upon what we want to do here, we're going to be able to move both ways with rewriting using these properties. And so let's go ahead and take a look at these two examples that I've got screenshots of here. And in the first example, what I want you to notice is that we are expanding our expression here. So the very first thing I want us to notice is that the thing we are taking a log of, it looks like we're using a natural log. Recall that this is the same thing as just log base e of 5 times x to the 7th over y. But we're taking this natural log here, but the thing I want to notice first is the fact that it has a quotient on it. So in terms of expansion, we're going to write a rule or an order in which to expand. So what we're going to be looking for within our parentheses here first is always going to be what we call a quotient. Okay, so quotients are pretty obvious. These are these things that are usually represented with a fraction, but that'll be the first thing we split up, followed by the next thing we split up, which are going to be products. Okay, and then the last thing we tend to expand are our powers. So going through this order right here, we can see that we have right here a quotient. So the very first thing we're going to do is we're going to say that since we have a quotient of everything on top with everything on bottom, then we're going to rewrite this as log base e, or ln, of everything on top. And using our quotient property here that says, well, the log of a quotient is the difference of these two logs, we're going to say that this is instead minus instead of divided by. We're going to say the ln of y. So you can see that we take the ln of everything on top minus the ln of everything on bottom here. From this point, what we're looking for is this: keeping our eyes peeled for any products, quotients, or powers, or quotients, products, powers in that order. So when I look inside of both of my logarithms here, and I suppose I mean here and here where I have a 5x to the 7th and a y, what I'm looking for are any quotients. And so in this first one here, I see that I have no quotients. But what I do see next on my list is that it does have a power. So that's going to be our first stop there. When we look over here in this set of parentheses, we see that it has no quotients, no products, and no powers. So in cases where we have no products, quotients, products, or powers, then we're going to say that that term, such as this term ln of y, cannot be expanded any further. So with this, what we have right here, it looks like in our product we have two factors. Our first factor is 5, and our next factor is this x to the 7th. So as we expand this even further, we would say that using our product property, the log base b of a m times n is really the log base b of m, which is the first product or factor in our product, or plus the log base b of n, which is the second factor in our product. So we'll do the log base e, or in this case natural log of the first thing in our product, 5, plus the natural log of the second thing in our product, which is x to the 7th. And then we'll just bring down this minus ln of y that was just sitting off on the right side of this expression right here. So looking at what we have here, looking in the 5 here, or at least in this logarithm's argument, I see no quotients, I see no products, I see no powers. That's something that I would say that is all the way expanded. But as we look in this next set of parentheses here, I say I see no quotients, I see no products, but I do see a power. So using our power property, all we're going to do is we're going to take that 7 and we're going to reposition out in front. And we're going to say that our final expanded expression would say ln of 5 plus 7 times the ln of just x minus the ln of y. And so we'll put a box around this and we'll say that this is our completely expanded expression. So a question that I get a lot is, how do you know when you've expanded all the way? So this is our expanded expression. And again, I want to reiterate this fact that you look inside all of your logarithmic arguments here and you look for things like quotients, products, and powers, and if you don't spot any, then we'd say we are as expanded as we're going to be able to get. So now in this next example, our goal will be to do the exact opposite, to use these rules to recognize patterns like a sum of 2 logs, or a difference of 2 logs, or a power of 2 things here, or a product here that could be expressed as a power. What we're going to be looking for are things like that in order to put it back together into expressions of a single log, okay, of a single argument. And so looking down here where it asks us to condense this expression, what I'm going to do is I'm going to recommend an order in which to expand, in which to condense, pardon me. So because to condense is kind of the opposite of what we did up here with expansion, what we're going to see is that the order in which we do things is going to be flipped here. So that is to say, we're going to put powers back, and then we're going to rewrite products, okay, next. So products still in the middle like it is up here, and then we're going to rewrite quotients last. And by rewrite, what I mean is we're kind of putting things back together. So I didn't write rewrite up here. I wrote expand our quotients, products, powers. Here we're going to put powers back, rewrite our products, and rewrite our quotients. So the way this is going to behave is this. We have 3 single logarithms here of single arguments, just a 9, just a 2, just a 3. And in terms of looking for powers, recall that our power property says that that power actually gets put out in front. And so if we're going to put that power back, what we're doing is really sending it back up on the argument here, such as this m here, so that we get log base b of m to the n. So in this particular case, because I see a power here, or what will be a power, we're going to put this back up here, and what we end up with is just then log of 9. So this is a log base what? Well, this must be a base 10, or a common log if we haven't written the base. So we're just going to write log of 9, assuming that it's a base of 10. And then we say that this would be log of 2 cubed minus the log of 3. So just to simplify this 2 cubed, because I can, I'm going to rewrite this again. I say log of 9 plus log of 2 cubed, which is 8, minus the log of 3. So now looking at what we have left, I notice that we have a sum here and then a difference here. So kind of working left to right, but also kind of looking for products first. I see that we have a product here with our sum. So we're going to put these 2 logs back together. And the way this works is we're going to write this as a single log having the same base. So if this is log 10, this is log 10, this is log 10. And then what we're going to do is we're going to say because this is a plus, then really it must be a product of our 9 and our 8 that got us there to begin with. So we have log of 9 times 8 minus that log of 3 that we have over here. So continuing this on, I'm just going to simplify 9 times 8. Looks like we get a 72, okay, minus the log of 3. But what we're going to have to do is put back last now our quotients, and quotients were easily recognizable by the difference here that occurs. So because we have log of 72 minus the log of 3, and they have the same basis, okay, then what we could do is we could rewrite this as a single log of a quotient, where the top of our quotient is going to be this first argument, and the bottom of our quotient would be this second argument. So just to simplify this here, it seems to me that 72 is divisible by 3. So if we divide 72 by 3, we should at least check. We say 24. This is the same thing as the log of 24. And so I'm going to put a box around this, and we're going to say that this is our completely condensed expression. So our initial expression is equivalent to this new expression, except for the benefits here is that we can write it as a single log of a single argument, whereas sometimes it's better to write a log of a single argument as a bunch of logs of single arguments. Cheers.